When dealing with three variable systems, our whole goal is to eliminate one of the variables to turn it into a two variable system, and then we can solve it as we've been doing. So just like before, we can use either substitution or elimination. In this case, we'll do elimination. So our first step is we pick any pair of equations, so just pick two of them. I'll go ahead and do the first two to start and choose one variable to eliminate. So in this case, either y or z would be pretty simple. I'm going to choose z. So to eliminate z, I'm going to have to multiply that second equation by 6. So I'm going to pull this pair out to make it easier to see. We have 3x plus 9y plus 6z equals 3. We multiply everything by 6. We get 12x plus 6y minus 6z equals 12. So we take that pair. I'm going to go ahead and eliminate, add them together. So we get 15x plus 15y equals 15. So there's one equation. Now we need to take another pair of equations, eliminate that same variable. So this time I'm going to look at equations 2 and 3. In order to eliminate that, those I don't have to multiply by anything. I can just stack them on top of each other. So we'll do 2x plus y minus z equals 2. X plus y plus z equals 2. So our whole goal here is we have to eliminate that same variable. So we're getting rid of z. Just add them together. We get 3x plus 2y, z's go away, equal 4. So now I've turned this into just a system of two equations, and we will solve this one. 15x plus 15y equals 15, and 3x plus 2y equals 4. So now we can solve this as we would any normal system, elimination or substitution. We'll stick with the theme and just go ahead and do elimination. To eliminate, I'm going to multiply the second equation by a negative 5, and that turns into negative 15x minus 10y equals negative 20. The other equation stays the same. Add them together, x's go away. 15 minus 10, 5y, 15 plus negative 20, negative 5. And we get y equals negative 1. Now we just have to kind of work our way back through all the equations to solve for the other variables. So first I'll come over here and solve for x. So we have 3x plus 2 times negative 1 equals 4. 2 times negative 1 is negative 2. So add it to the other side. 3x equals 6. And x equals 2. So now to solve for our last variable, go up to the very beginning, take any equation you want. We have x is 2, y is negative 1. Now we need to solve for z. 2 plus negative 1 is 1. Whoops, that should be a z there. Subtract the 1 over, and z equals 1. So our final answer would be x is 2. Y is negative 1, z is 1. Remember, for these variables, when we list them out, it goes x, y, z. So to recap with elimination, our whole goal is to eliminate one of the variables and turn it into a system of two equations. So first I picked the top two equations, got rid of z. Then I picked the bottom two equations, got rid of z again. That's where these two came from. And then we stacked those two on top of each other to create a system of two equations, went through the whole process again. And then once you start getting answers, you just keep working backwards, plugging them in, solve for whatever other variable you can find. So now our other option is to solve by doing a substitution. Again, the goal is the same here though, where we want to eliminate one of the variables in two different equations so it turns into a system of two variables. So in this case, substitution, same as with substitution of just two variable equations, pick a variable, solve for it. So I'm going to solve for x in this last equation. And we get that x equals 2 minus y minus z. So now that I have that, I'm going to take that expression for x, go to the other two equations, plug it in for x. Here's where we're going to use parentheses and be careful. So we have 3 times 2 minus y minus z plus 9y plus 6z equals 3. And now we just want to simplify it, get it into standard form. So distribute that 3 in. 6 minus 3y minus 3z plus 9y. Combine our like terms. And we get 6y plus 3z equals negative 3, because I subtracted that 6 to the other side. So there's one of our equations. Now let's do the second one. And we have 2 times, again our x was 2 minus y minus z plus y minus z equals 2. Now again, same as before, we just want to distribute and then get this into standard form. So we have 4 minus 2y minus 2z plus y minus z equals 2. Combine all of our like terms. And we have negative 2y plus y is a negative y minus 3z. Subtract the 4 to the other side equals negative 2. So now, remember, our goal is to eliminate one of the variables. We just eliminated x. So now we just have a system of 2 equations. We have 6y plus 3z equals negative 3. Negative y minus 3z equals negative 2. Now we can solve from here. And you can switch back and forth. So at this point, elimination is easier. So you could use elimination to solve, or you could stick with substitution. It doesn't matter if you flip between, as long as you're using all the right methods to solve. So in this one, again, to keep consistent, I'm going to use substitution. Really, elimination would be easier here. But if we wanted to do substitution, this is the easy one to solve for y. And we get y equals, if we add y, add 2, negative 3z plus 2. Plug that in the other equation. 6 times negative 3z plus 2 plus 3z equals negative 3. Distribute negative 18 and 12. Combine like terms. We get negative 15z equals, subtract it, negative 15. And then we get z equals positive 1. So now we just work our way back up. We already have y solved for. Let's just plug a 1 in for z. So negative 3 times 1 plus 2. Negative 3 times 1 is negative 3 plus 2 gives us negative 1 for y. And now work backwards one step further. Notice we already have, let's switch colors here. We already have x solved for again, so we can just plug both into there. We have x equals 2 minus y, which is negative 1, minus z, which is 1. Well, 2 when you do a minus and negative, so it turns into 2 plus 1 minus 1, which is just 2. So notice this is the same problem as on the previous slide. We have x equals 2, y equals negative 1, z equals 1. With these 3 variable systems, neither method is going to be necessarily clean, but it's just a matter of keep your work organized, keep it straight, where your whole goal is to get rid of one variable, turn it into a 2 variable system, and then go from there.